Welcome to the Explainer. You know that feeling when you search for a book on, say, epic fantasy quests, and you get back a history of the Oregon Trail? Yeah, it's frustrating. Today, we're going to fix that. We're going to build a smart book recommender from the ground up, one that moves way beyond just clunky keywords to a system that actually understands the true meaning behind what you're looking for. So here's the game plan. First, we're going to break down why traditional keyword search just doesn't cut it anymore. Then we'll get into the really cool stuff, what semantic search is and how vector databases power it all. After that, we'll roll up our sleeves, get the project set up, walk through the essential code, and finally see our brand new intelligent recommender in action. All right, so first things first, let's talk about a problem that I promise every single one of us has run into. Search results that are just confusing and totally irrelevant. I mean, have you ever typed something super specific into a search bar only to get results that are completely different just because they happen to share one single unimportant word? It's an incredibly common and, let's be honest, annoying experience. This right here is the perfect example of the keyword problem. A traditional search system is basically blind to what you actually mean, your intent. It's just playing a game of match the word. It sees shoes, checks the box, and thinks its job is done, completely ignoring the most important parts of your search, lightweight and running. And look, this isn't just a minor inconvenience. This has real-world bottom-line costs. Industry studies show that when a search engine fails to understand what a user is actually looking for, it can cause a massive 40% drop in conversions. To put that in perspective, 4 out of every 10 potential customers just give up and go somewhere else. Okay, so we've established the problem. How in the world do we fix it? Well, the answer is a fascinating technology called semantic search. It's all about shifting from just matching words to actually understanding meaning. Semantic search is a whole different ballgame. It's not just scanning for characters on a page. It uses powerful AI, like natural language processing, to figure out the intent and the context behind your search. It's about what you mean, not just the words you type. Here's the best way to think about it. Keyword search is like a dictionary. It's rigid, it can only find the exact word you look up. Semantic search, though, is like a really good advisor. It listens to your problem. So if you say, I'm looking for a story about a kid who finds out he has magic powers, it understands the concept and might recommend Harry Potter, even if you never use the word wizard. Okay, so this is where it gets really, really cool. How does all this understanding actually work under the hood? Well, that brings us to the engine that drives this entire thing. The vector database. So how does a computer get the meaning of a word? Well, for a computer, meaning is just math. An AI model will take a piece of text, whether it's one word or an entire book description, and it turns that meaning into a long, long list of numbers. That list is called a vector embedding. You can think of it like a set of coordinates, but for meaning. And in this meaning space, concepts that are similar, like king and queen, end up being very close together. And this is exactly where vector databases are brilliant. Think about a normal database. It's like a giant spreadsheet. You're always looking for an exact match. But a vector database plays a totally different game. It stores these numerical vectors of meaning. And when you search, it's not looking for an exact match. It's looking for what's closest, its nearest neighbors in that meaning space. And that's precisely why they're perfect for AI, for chatbots, and, you guessed it, for recommendation systems. All right, enough theory. We've talked about the why, so now let's get into the how. It's time to get our hands dirty and set up the project environment. And you know what? This is way easier than it might sound. It really just boils down to a few key steps. First, you'll spin up a free vector database cluster. We're using Weaviate, and just copy the URL and API key. Then, you'll pop over to OpenAI and grab an API key from them. And finally, you just need to put those 3 secret values somewhere your code can securely find them. That's it. Okay, environment's all set up. Now for the really fun part. Let's dive into the code that actually makes all of this work. So first things first, we have to tell our database what to do with our data. This little chunk of Python right here is the instruction manual. We're telling Weaviate, hey, for your vectorizer, I want you to use the text-to-vec OpenAI module. Specifically, we're pointing it to OpenAI's ADA002 model. This is the command that tells the AI to turn all our book descriptions into those powerful vector embeddings. Okay, now this is the magic right here. Look closely at this query. We're not doing a keyword search. We're using that special method, .with_near text. What this does is it takes our concept, famous battles in history, turns that phrase into a vector, and then it goes into the database and finds the book vectors that are its closest neighbors. It's searching by meaning, not by matching words. So, we've seen how to query the database, but how does a real user do it from a website? Well, that's where this API endpoint comes in. This is the bridge. It takes whatever the user typed in the search box, which we see here as query, and it wraps it up in that same dot with near text search we just saw. It then sends it off to the database and waits for the meaningful results to come back. All right, we've got the database configured, we've got the query logic, and we have an API to handle requests. Let's put it all together and see what this looks like for the end user. The front end itself is clean and simple, just how you want it. There's a search box where you type what you're looking for. When you hit submit, it calls that API endpoint we just looked at. The list of books that comes back gets stored in a React state variable, which immediately tells the user interface to update and show a beautiful grid of all the recommended books. It's a really smooth, modern workflow. You know, Adam from Weaviate really nailed it with this quote. By building a system like this, we're not just judging a book by its cover. We've created something that actually understands the themes, the concepts, and the ideas inside the books, which leads to a way better discovery experience. So just take a second and think about what we've done. We've gone from a simple, kind of dumb dictionary to a genuinely smart advisor. We've taken a huge step towards solving the age-old problem of search by understanding intent. And as this technology gets better and better, it really makes you wonder, what's next? What's the next great frontier in our quest to build machines that can truly understand us?